Hello there, and welcome to this quiet corner of the cosmos. Perhaps it has been a long day, or maybe you find solace in contemplating distant planets and drifting moons as you prepare for rest. Whatever brings you here, this gentle journey is for you. There is nothing for you to do now but simply be. Allow your breath to deepen, your thoughts to soften, and your body to feel light, as if gravity has gently loosened its hold and you are beginning to float quietly through the vastness. Tonight, we shall embark on a serene drift through our solar system. Our path will not be a straight line, but rather a series of soft spirals, guiding us from sunlit planets and shimmering rings to shadowed craters and the quiet mysteries of frozen oceans hidden beneath icy crusts. This is a story whispered not in hurried numbers, but in the gentle dance of magnetic storms, the subtle tilt of planetary axes, and the soft glow of moons in the dark. From worlds that spin on their sides to the quiet wonder of diamond rains and the ancient sunlight still making its way across the void, every orbit holds something uniquely strange and beautiful. We will journey slowly, with a gentle pace, exploring one sleepy cosmic detail at a time. And as we prepare to begin, if these quiet explorations bring you a sense of calm or offer a peaceful way to conclude your day, you might consider gently tapping the like button and subscribing to the channel Sleepy Stargazer. It helps others discover this tranquil space, one sleepy soul at a time. Now, let us begin our quiet voyage. Drifting further into the quiet expanse, we encounter Neptune, a world where the very air moves with astonishing speed. Though it resides as the farthest known planet from our Sun, Neptune cradles within its atmosphere the swiftest winds in our entire solar system. These ethereal currents gently sweep through its upper layers, reaching speeds that quietly surpass 2,000 kilometers per hour, a velocity greater than the speed of sound here on Earth. To imagine this gentle rush, consider it approximately 5 times the speed of a commercial jet as it glides through our skies. It is believed that these remarkable winds draw their energy from the planet's own internal warmth, a subtle heat that continues to radiate outward, even amidst the profound chill of its surface. Neptune's atmosphere, a serene blend of hydrogen, helium, and methane, is where these winds quietly sculpt vast, swirling storm systems within the planet's pale blue clouds. It is a world of tranquil beauty, a frozen realm held in a state of constant, supersonic motion, a quiet ballet of cosmic forces. As our gentle journey continues, we find ourselves drawn to the quiet red planet, Mars, where a canyon of continental proportions quietly awaits our gaze. Stretching for more than 4,000 kilometers across the Martian equator, this grand feature, known as Valles Marineris, stands as the largest canyon system within our solar system. Its immense span could comfortably stretch across the entire width of the continental United States, inviting a sense of quiet wonder at its scale. In certain places, its depths plunge more than 7 kilometers, a profound descent that is over 5 times deeper than Earth's own Grand Canyon, speaking to the planet's ancient, powerful forces. Scientists quietly ponder its origins, believing it to have formed through a serene combination of tectonic stretching, gentle volcanic activity, and the slow work of erosion over eons. Unlike the canyons of our home world, which are typically sculpted by the persistent flow of rivers, Valles Marineris may have quietly opened as the planet's crust slowly cracked and pulled apart, a testament to deep geological movements. It remains a profound, ancient scar upon Mars' tranquil surface, softly hinting at a powerful geological past now peacefully frozen in time, inviting us to simply observe and imagine. As we gently turn our gaze toward Venus, a world so often called Earth's sister planet, a profound difference emerges in its silent depths. Despite sharing a similar size, mass, and even a comparable composition to our own Earth, Venus quietly lacks one crucial planetary feature: a global magnetic field. On Earth, this protective magnetic shield is born from the slow, swirling motion of molten iron deep within its outer core, a gentle dynamo that safeguards our world from the sun's energetic radiation. Yet, for Venus, the story is different. Its core appears to be either sluggish in its movement or perhaps even solidified, preventing the kind of dynamic effect needed to awaken such a field. Without this invisible embrace, Venus's delicate atmosphere is left exposed, constantly brushed by the solar wind, which, over eons, has quietly stripped away its lighter elements. This absence of a magnetic field helps us understand why Venus, a world that might once have mirrored Earth, slowly transformed into the furnace world we observe today. Now, let us quietly consider a truly wondrous possibility: the gentle descent of diamonds upon the distant worlds of Uranus and Neptune. Deep within the swirling atmospheres of these serene ice giants, the conditions are thought to be so profound, so extreme, that they might just give rise to something truly extraordinary: a quiet rain of diamonds. These vast, blue worlds are enshrouded by thick layers of methane gas, and under the immense, patient pressure and the deep internal heat, scientists quietly believe that this methane can slowly break apart, releasing its carbon atoms. These liberated carbon atoms then begin to compress, forming tiny crystalline structures, shaping themselves into delicate diamonds that slowly, softly, drift down toward the planet's core. Laboratory experiments have gently simulated this very process, quietly showing how hydrocarbons can indeed condense into diamond under precisely the right, profound conditions. If this theory, whispered by the cosmos, proves to be correct, then silent storms of glittering crystals might be forever drifting through the deep blue darkness of these distant, tranquil gas giants. As we continue our quiet exploration, we find ourselves gently resting upon Earth, a world uniquely graced by the slow, rhythmic dance of plate tectonics. This intricate system, a dynamic network of shifting crustal plates, quietly floats atop the planet's mantle, a feature that profoundly enables life as we know it. These plates, in their unhurried motion, sculpt our world, giving rise to the gentle tremors of earthquakes, slowly building majestic mountains, and subtly recycling carbon dioxide, a process that delicately regulates our climate over vast stretches of geologic time. In the quiet expanse of our solar system, no other planet has yet revealed clear evidence of such a profound process. While Mars and Venus display surface fractures and ancient volcanic features, they appear, by comparison, to be geologically still, their surfaces largely unchanging. Earth's plate tectonics may well be a fundamental part of what makes our home so wonderfully habitable, quietly driving the long-term cycles that stabilize its temperature, cradle its oceans, and allow the continents to drift and reshape themselves across the eons. Quietly, we can ponder that some asteroids are not solitary wanderers, but instead, they host their own moons. While our minds might often picture these rocky bodies drifting alone, a surprising number of them are accompanied by smaller companions, gently orbiting their parent asteroid. These tiny satellites are often fragments that have been quietly captured by gravity, or perhaps they formed alongside their larger partner, bound together in a cosmic dance. The very first of these asteroid moons to be discovered was Dactyl, a small body that gracefully orbits the asteroid Ida, a revelation brought to us by the Galileo spacecraft in the year 1993. Since that time, many dozens more of these delicate asteroid moon systems have been quietly observed, some even featuring multiple moons or intriguing binary arrangements where two asteroids softly circle each other. These miniature celestial systems gently remind us that even within the immense quietude of space, the subtle pull of gravity can weave the smallest of objects into serene, drifting partnerships, moving together through the cosmic night. As our quiet journey brings us closer to Mercury, we find it cradled not by a true atmosphere, but by a ghostly exosphere. Unlike our own Earth, Mercury does not possess a thick, comforting blanket of air to hold warmth or gently scatter the sunlight. Instead, it is enveloped by a delicate, almost ethereal shell of particles, a near vacuum where individual atoms drift and softly rebound without the frequent collisions we might expect. This whisper-thin exosphere is composed of atoms that have been gently lifted from the planet's surface, perhaps by the soft breath of the solar wind or the quiet touch of micrometeoroid impacts, revealing elements such as sodium, potassium, and oxygen. Because Mercury's gravitational embrace is not strong enough to hold a substantial atmosphere, these particles are forever escaping into the vastness of space, only to be quietly replenished from the surface below. The result is a shimmering, almost invisible envelope of scattered atoms, a silent testament to the planet's unique interaction with the cosmos, detectable only with the most sensitive instruments. In the heart of our solar system, the Sun quietly undergoes a profound transformation, gently shedding millions of tons of its own mass with each passing second. This remarkable process, known as nuclear fusion, sees over 4 million tons of its substance converted into pure energy. Deep within its luminous core, hydrogen atoms gracefully merge to form helium, releasing the light and warmth that softly bathes our solar system. This radiant energy then drifts outward in every direction, tenderly warming the planets, stirring gentle winds, and nurturing the delicate tapestry of life here on Earth. While this continuous loss is but a whisper compared to the Sun's immense total mass, over the vast stretches of billions of years, it steadily accumulates. Eventually, the Sun will quietly exhaust its hydrogen fuel, beginning a slow, majestic transformation. Yet, for now, it continues its steady, serene burn, offering a tiny part of itself with every quiet moment that unfolds. As our quiet journey through the cosmos unfolds, we gently turn our attention to Saturn, a planet renowned for its breathtaking rings. Yet these magnificent structures, which seem to embrace Saturn in an eternal dance, are not destined to last forever. Slowly, almost imperceptibly, they are beginning to fade. These ethereal rings are gradually drawn inward, pulled by the planet's immense gravity and guided by the subtle forces of Saturn's magnetic field. This gentle descent is often referred to as ring rain, a quiet process where countless ice particles and charged materials drift softly toward the planet over vast stretches of time. Data gathered from the Cassini spacecraft has hinted that these rings might be relatively young, perhaps less than 100 million years old, a mere blink in the grand cosmic timeline. And so, in another few 100 million years, this shimmering spectacle could quietly vanish, becoming a memory in the silent history of our solar system. Though they appear timeless to our eyes, Saturn's rings are a temporary, wondrous feature, a fleeting celestial artwork destined to eventually dissolve into the planet itself. Turning our gentle attention now to the red planet, Mars, we find a world renowned for its rusty, desert-like landscapes and for the colossal dust storms that, from time to time, quietly envelop its entire sphere. These vast atmospheric events can linger for weeks, sometimes even months, softly obscuring the sunlight and subtly reshaping the planet's ancient surface. The dust itself is remarkably fine, often remaining suspended in the thin atmosphere, casting a hazy, reddish glow across the Martian sky. Some of these storms begin as mere gentle gusts, yet they can expand with surprising speed, fueled by intricate feedback loops between the sun's warmth, the whispering winds, and the planet's varied topography. We recall, for instance, how in 2018, such a sweeping storm quietly brought an end to the Opportunity rover's long mission, as its solar panels were gently choked by the pervasive dust. Even in the absence of rain or vast oceans, Mars remains a world of quiet activity and subtle, restless motion. As our quiet journey through the cosmos unfolds, we gently turn our attention to Europa, a moon of Jupiter, where a salty ocean may lie hidden beneath its icy crust. Beneath this frozen shell, there is compelling evidence suggesting a vast subsurface ocean of liquid water, kept from freezing solid by the gentle, rhythmic tidal forces exerted by Jupiter's immense gravity. These subtle gravitational flexes generate a quiet warmth deep within Europa's interior, cradling this hidden sea. The moon's surface itself whispers clues, streaked with dark lines and ridges that hint at shifting ice, while spacecraft have quietly detected magnetic signatures and chemical traces, all lending support to this profound ocean hypothesis. What makes Europa especially captivating as we drift into slumber is the serene possibility that this dark alien ocean, warmed from below and sealed beneath its icy canopy, could quietly harbor the very ingredients for life, a silent testament to the universe's endless wonders. As our quiet gaze settles upon the tranquil red planet, Mars, we discover a truly monumental presence, a volcano that ascends to heights far beyond anything found on Earth. This is Olympus Mons, the most colossal volcano in our entire solar system, gently reaching nearly 22 kilometers above the serene Martian plains. To put this into perspective, it stands almost 3 times the height of Earth's majestic Mount Everest. Its vast base is so expansive that it could softly embrace an area the size of an entire state, like New Mexico. This gentle giant was sculpted by countless eruptions, unfolding over millions of years, growing to such an immense scale, partly because Mars does not experience the shifting dance of plate tectonics. On our own world, volcanic hotspots tend to drift over time, quietly giving birth to long chains of islands, much like the Hawaiian archipelago. Yet, on Mars, the crust remains peacefully still, allowing magma to emerge from the very same point, time and time again. The quiet culmination of this process is a single, massive shield volcano, which now silently looms, a timeless sentinel in the soft Martian night. As our quiet journey through the cosmos unfolds, we find ourselves drawn to the majestic rings of Saturn, which, despite their grand expanse of more than 280,000 kilometers, are astonishingly thin. In most places, these ethereal rings measure less than 100 meters in thickness, a dimension far more delicate than many of the buildings that grace our cities. Composed primarily of water ice, the countless particles within these rings vary gently in size, from the finest grains of dust to boulders as large as a house. When the soft sunlight passes through this vast ring zone, they can seem to almost disappear from view, much like a sheet of glass turned precisely on its edge. Their remarkable flatness is a testament to the delicate balance of the planet's gravity, the quiet self-organization of billions of icy fragments, and the subtle influence of small shepherd moons. From a distance, they present a vision of solid grandeur, yet up close, they reveal themselves to be a truly delicate and ethereal wonder. As our gentle journey through the solar system unfolds, we arrive at our own tranquil home, Earth, which holds a unique distinction as the densest of all the planets. This means that within each cubic centimeter, our world cradles more mass than any other celestial body in our planetary neighborhood, a testament to its rich composition of a metal-heavy core and a silicate mantle. Earth's density settles at approximately 5.5 grams per cubic centimeter, a figure that surpasses even the immense gas giant Jupiter, despite its vastly greater size. This remarkable density plays a profound role in the generation of Earth's protective magnetic field, a gentle shield born from the slow, swirling motion of molten iron deep within its outer core. Our planet's internal structure, compact and layered, not only shapes its gravitational embrace, but also influences its geology and provides a steadfast protection from the vastness of space. Within the heart of our solar system, the sun quietly resonates, much like a vast cosmic instrument. While its melodies are far beyond the range of human hearing, this luminous star is perpetually alive with pressure waves, gently rippling through its incandescent layers. These subtle oscillations, born from the rising and falling currents of plasma, generate sounds of an ultra-low frequency, far beneath what our ears can perceive. Scientists, with their patient curiosity, explore these vibrations through a field known as helioseismology. By carefully tracing how these waves journey and echo within the sun's immense body, researchers are able to map its intricate internal structure in a manner not unlike how geologists use seismic waves to unveil the Earth's hidden depths. These solar serenades quietly reveal the unseen flows, the delicate dance of magnetic activity, and the profound dynamics of fusion deep within the sun's core. In this gentle way, our sun is always humming, softly, continuously, whispering its ancient secrets through the language of vibration and rhythm. As our quiet gaze drifts toward Venus, we notice a gentle peculiarity in its motion. Unlike the majority of its planetary companions, Venus quietly spins in the opposite direction, a serene phenomenon known as retrograde rotation. This means that if we were to observe a sunrise from its surface, it would softly emerge from the west and gracefully set in the east. Even more remarkably, its rotation unfolds at an incredibly unhurried pace. A single day on Venus stretches out longer than its entire year, taking a full 243 Earth days to complete just one gentle turn. Scientists continue to ponder the quiet reasons behind this unique rhythm, with one possibility suggesting a profound, ancient collision in its early history that subtly altered its spin. Another theory whispers of the sun's tidal interactions, which may have slowly and gently nudged its axis over vast stretches of time. Whatever the ultimate cause, Venus remains a solitary, slow-turning world, quietly embracing its reversed, tranquil rhythm. As our quiet journey through the solar system continues, we find ourselves drawn to Jupiter, a gas giant that is not only the largest planet, but also a silent monarch of moons. Over 90 natural satellites have been identified gently orbiting this colossal world, with new discoveries still quietly unfolding. Among them, the four largest, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons, named for Galileo Galilei, who first observed their serene dance in 1610. Yet, beyond these familiar giants, a quiet swarm of smaller, irregular moons drifts, many believed to have been gently captured from passing cosmic wanderers. Some of these tiny companions even trace their paths backward, while others measure just a few kilometers across. Together, they form a miniature solar system, quietly bound by Jupiter's immense gravity, each a silent testament to the planet's long and captivating history. As our quiet journey brings us closer to the Sun, we find ourselves gently observing Mercury, a world of stark contrasts. While its days are intensely scorching and its nights deeply freezing, it holds a quiet secret: ice. This unexpected presence resides at its poles, nestled deep within craters that remain perpetually untouched by sunlight. In these permanently shadowed regions, temperatures linger cold enough for water ice to exist, acting as natural freezers that have preserved this ice for millions of years. Gentle radar reflections from spacecraft, such as Messenger, have quietly confirmed the presence of these bright, icy patches. Scientists softly ponder that this water may have arrived from ancient comet impacts, or perhaps from quiet volcanic outgassing long ago. Thus, in the heart of one of the solar system's warmest planets, ice quietly endures, locked in darkness, shielded by crater walls from the relentless, golden solar blaze. As our quiet journey extends to the distant reaches, we find that Pluto's very heart may hold a hidden ocean. The bright, heart-shaped feature on its surface, known as Sputnik Planitia, is not merely a scenic landmark. It may, in fact, be the gentle surface expression of a vast ocean lying deep beneath. Even though Pluto drifts far from the Sun in temperatures cold enough to freeze nitrogen, quiet evidence from the New Horizons spacecraft suggests that a layer of liquid water might patiently lie beneath its icy crust. The immense weight of the Sputnik Planitia Basin and its apparent geological activity softly hint at a slushy, convecting subsurface. If this ocean truly exists, it could be kept in its liquid state by the gentle warmth from radioactive decay within Pluto's core, shielded by insulating ice layers above. Thus, even in the frozen, distant reaches beyond Neptune, a hidden sea may quietly persist, a testament to the universe's quiet wonders. As we continue our gentle drift through the solar system, we quietly approach the asteroid belt, a region often imagined as a dense field of tumbling rocks. Yet, in truth, this vast expanse is mostly empty space. Contrary to the vivid scenes of science fiction, a journey through the asteroid belt would not involve a frantic dance of dodging obstacles. Instead, this expansive realm, nestled peacefully between the orbits of Mars and Jupiter, holds millions of rocky bodies, each separated by immense, silent distances. A spacecraft, on its quiet passage, would almost certainly glide through without ever encountering another object. The collective mass of the entire asteroid belt is surprisingly small, less than 5% of our own moon's gentle weight. Its most prominent members, like Ceres and Vesta, account for the majority of this mass, while the rest are scattered fragments, ancient building blocks that quietly drift, never quite coalescing into a full planet in the early, formative years of our solar system. And so, our quiet gaze now settles upon Uranus, a world that seems to gently roll around the Sun. While most planets spin gracefully, tilted just a little on their axis, Uranus presents a unique celestial ballet. It is tipped so profoundly, with an axial tilt of 98 degrees, that it appears to simply roll along its vast orbital path. This extraordinary orientation means that, for long stretches of its journey, one of its poles points almost directly toward the distant sun, creating seasons of an extreme and peculiar nature. Each pole, in its turn, experiences 42 Earth years of continuous daylight, followed by an equally long period of 42 years shrouded in darkness. The precise reason for this dramatic tilt remains a quiet mystery, though some whisper of a colossal collision in the ancient past, perhaps nudging it sideways into this unusual dance. This tilted posture bestows upon Uranus one of the most intriguing and strange climates found anywhere in our solar system. As our quiet journey continues, we now gently approach Jupiter, a world of immense beauty, yet one veiled in an invisible embrace of energy. This gas giant is encircled by a magnetic field of extraordinary power, the most potent among all the planets in our solar system. Within this vast magnetic embrace lie radiation belts of such intensity that they could gently dismantle any unprotected spacecraft venturing too close. These belts are softly filled with charged particles, patiently trapped by the planet's magnetic field, forming zones of high-energy radiation. They are akin to Earth's own Van Allen belts, yet on a scale that is vastly, profoundly more powerful. Even Jupiter's largest moons, as they quietly orbit, are bathed in this radiation, a gentle yet persistent force that can subtly influence their surfaces and the quiet potential for habitability. For any spacecraft wishing to linger in Jupiter's orbit, special shielding measures must be thoughtfully considered, or perhaps a path through less intense radiation zones must be carefully chosen. It is a world of breathtaking wonder, quietly wrapped in a magnificent, unseen power. Quietly, we can consider the sun's profound dominance, not just as a source of light and warmth, but as the very anchor of our solar system. It quietly holds nearly all the mass within this cosmic neighborhood, accounting for over 99.8% of everything. This means that all the planets, their moons, the countless asteroids, the distant comets, and even the finest dust particles collectively make up less than 1/4% of the total. It is this immense, silent mass that exerts a gentle gravitational pull, binding everything into its graceful orbit, from the smallest grains in the asteroid belt to the most distant comets in the Oort cloud. And it is this very mass that fuels the steady fusion reactions deep within its core, quietly transforming hydrogen into helium, and in doing so, softly flooding the vastness of space with the gentle energy of day. As we journey further into the outer reaches of our solar system, we begin to perceive a gentle truth. There are more dwarf planets than the familiar classical planets. Beyond the serene orbit of Neptune, a scattered population of icy, distant objects quietly drifts, many of them large enough to be classified as dwarf planets. Pluto, of course, is the most well-known among them, yet it is but one of many. Others, such as Eris, Haumea, and Makemake, share this tranquil status, and with each passing moment, more candidates are gently being discovered within the distant Kuiper belt and even further beyond. Indeed, the quiet count of dwarf planets may eventually far exceed that of the 8 classical worlds we know. These small, round worlds are like ancient relics, untouched and timeless, holding within them the quiet whispers of the early solar system. Though they journey through the cold, deep shadows of space, they hold precious clues to the formation of everything we quietly observe. Let us now quietly consider the curious rhythm of Venus, where a single day unfolds more slowly than its entire journey around the sun. This serene planet possesses one of the most unhurried rotations in our cosmic neighborhood, taking a full 243 Earth days to complete just one gentle spin upon its axis. Yet, In a quiet contrast, it completes its graceful orbit around the Sun in a mere 225 Earth days. This means that on Venus, the time from one sunrise to the next stretches out longer than a full year. This languid, almost dreamlike spin also contributes to the profound conditions upon its surface, where temperatures rise to a heat so intense it could softly melt lead. When we combine this with its thick, veiled atmosphere, heavy with acidic clouds and crushing pressure, Venus reveals itself as a world of slow, simmering warmth and days that linger in an eerie, sunless embrace. Drifting further into the outer reaches of our solar system, we encounter Titan, Saturn's largest moon, a world where lakes and rivers flow, yet they are not made of water. Instead, these serene bodies of liquid are composed of methane and ethane, quietly shaping a landscape sculpted by the gentle touch of cold chemistry. Titan is the only other place we know of in our solar system where stable liquids grace a surface, creating a familiar yet profoundly alien environment. Its thick, nitrogen-rich atmosphere cradles weather systems, bringing forth methane rain and even seasonal storms that sweep across its vast expanses. Some of these tranquil lakes stretch for hundreds of kilometers, reflecting the dim light of Saturn. And beneath this icy surface, scientists quietly ponder the possibility of a subsurface ocean of water, hidden away in the depths. Titan, in its quiet grandeur, presents us with familiar shapes: clouds, rivers, and coasts, all built from substances that whisper of a different kind of cosmic existence. And so, our quiet gaze now settles upon the red planet, Mars, and its two tiny, misshapen companions, Phobos and Deimos. These small celestial bodies, unlike the more familiar spherical moons, bear a striking resemblance to asteroids, with their irregular, rocky forms and surfaces deeply pockmarked by countless craters. Many scientists gently suggest that these may once have been wanderers from the asteroid belt, eventually drawn into Mars's gravitational embrace long, long ago. Their peculiar orbits and surprisingly low densities seem to whisper support for this idea, though other quiet theories ponder whether they might have emerged from the scattered debris of a colossal ancient impact. Phobos, the inner moon, is slowly, almost imperceptibly, spiraling inward, destined one day to gently break apart or softly merge with the planet below. Meanwhile, Deimos, its companion, is quietly drifting further and further away. These little moons are like silent passengers in the vast cosmic ocean, quiet remnants of a distant, chaotic past. And so, our quiet gaze now settles upon Jupiter, a world that softly glows with its own internal warmth. Unlike many of its planetary companions, Jupiter gently releases more energy than it quietly absorbs from the distant sun. This subtle internal radiance is a lingering echo from its very formation, a kind of gravitational energy that was quietly set free as the planet's immense mass slowly collapsed together in the cosmic dawn. Over the eons, it continues to contract ever so slightly, a gentle process that continuously generates this deep, abiding heat. This warmth, in turn, quietly fuels Jupiter's magnificent and turbulent weather systems, giving rise to its colossal storms and the serene, swirling bands that adorn its surface. When observed in the infrared spectrum, Jupiter shines with a soft, persistent light, much like a smoldering ember hidden beneath its vast cloud layers. It is not a star, yet in its early days, it almost became one. Had it gathered just a little more mass, it might have quietly ignited, becoming a gentle, failed sun in our celestial neighborhood. Our journey now brings us to the quiet story of Neptune, a world unveiled not by a direct gaze through a telescope, but through the elegant language of mathematics. Unlike its planetary siblings, Neptune's presence was first sensed through subtle whispers in the cosmos. Astronomers, observing the distant Uranus, noticed tiny, inexplicable wobbles in its orbit, slight deviations that could not be accounted for by the gravitational pull of any known celestial body. It was in the 1840s that two mathematicians, working independently across vast distances, took these curious motions and, through careful calculation, predicted the precise location of an unseen planet. And so, when telescopes were finally turned toward these calculated coordinates, Neptune quietly revealed itself, a testament to the profound power of celestial mechanics. This was a quiet triumph, confirming that even the most distant and unseen forces could be mapped and understood through numbers alone. Neptune thus became the first planet to be discovered on paper, a world brought gently into our awareness by the quiet certainty of equations long before its light ever touched a lens. Our quiet journey now brings us to Saturn, where a truly remarkable sight awaits at its north pole. There, a massive cloud pattern gently spins, forming the shape of a nearly perfect hexagon. This six-sided jet stream stretches over 30,000 kilometers across, a span wider than our own Earth, and has quietly persisted for decades, perhaps even centuries. Scientists suggest that this hexagon emerges from the way Saturn's atmosphere rotates, interacting with stable waves of air that become gently trapped around the pole. In quiet laboratory experiments, similar geometric shapes have been observed when fluids are rotated at varying speeds. The serene emergence of such a precise geometric form, naturally within a planetary atmosphere, remains one of the more surreal and elegantly peaceful phenomena in our solar system. As our quiet gaze drifts toward the sun, we encounter a curious enigma. Its atmosphere is, in fact, hotter than its visible surface. It might seem natural to assume that the very heart of its light would be its warmest point, yet this is not quite the case. The luminous surface, known as the photosphere, gently glows at a temperature of approximately 5,500 degrees Celsius. However, as we journey outward into the sun's ethereal outer atmosphere, the corona, we find temperatures soaring to over 1,000,000 degrees. This unexpected warmth, a quiet mystery, has intrigued scientists for many decades. One gentle theory suggests that subtle magnetic waves, originating deep within the sun's core, slowly transfer their energy upward, softly warming the corona from beneath. Another possibility whispers of countless tiny solar explosions, known as nanoflares, each contributing to this immense heat. In either scenario, the sun's outermost layers shimmer with a mysterious, searing warmth, far exceeding that of their radiant source. And so, our gentle journey now carries us to the Kuiper Belt, a realm teeming with icy worlds. Far beyond the orbit of Neptune, this vast, tranquil ring of frozen objects stretches for billions of kilometers from the sun. It is a quiet home to countless frozen bodies, among them the familiar Pluto, along with Eris, Haumea, and Makemake. These are not fiery stars or grand planets, but rather ancient remnants, patiently preserved from the very dawn of our solar system's formation. Some of these distant wanderers are spherical, earning them the classification of dwarf planets, while others tumble irregularly through the silent expanse. The Kuiper Belt shares a structural kinship with the asteroid belt, yet it is profoundly colder, holding within its depths a greater abundance of primordial ice. It is a fossil zone, a frozen archive, quietly safeguarding the very materials that once coalesced to build the outer worlds we know. Our gentle journey now carries us to the very edge of our solar neighborhood, where the Oort cloud may quietly stretch a light year from the Sun. Far beyond the Kuiper belt, and even beyond Pluto's furthest reach, lies this hypothetical shell of icy bodies. Though never directly observed, this vast, serene sphere of frozen debris is thought to softly encircle our solar system, extending nearly a light year into the quiet darkness. It is considered the likely source of long-period comets, which occasionally appear from the profound depths of space with their unpredictable, graceful orbits. These distant objects are only weakly bound to the Sun, and a passing star or the gentle pull of galactic tides could, in time, send one quietly hurtling inward. If the Oort cloud truly exists, it marks the serene, true edge of the Sun's gravitational influence, a distant, shimmering halo of icy wanderers, silently awaiting their moment. Now, as our gentle journey through the solar system continues, we quietly turn our attention to Io, a world of profound volcanic activity. This moon of Jupiter is a seething, restless sphere, its surface constantly being reshaped by a symphony of active volcanoes. Eruptions of molten sulfur and rock paint the landscape in vivid hues of yellow, red, and black, creating an ever-changing canvas. Some of these majestic volcanic plumes gently rise hundreds of kilometers into the silent expanse of space. This extraordinary activity is quietly driven by a process known as tidal heating. Io finds itself in a constant gravitational embrace, squeezed and stretched by the immense pull of Jupiter, along with the subtle gravitational tugs from its neighboring moons. The gentle friction generated by this ceaseless flexing warms its interior, quietly fueling its furious geological dance. Unlike Earth's ancient, cooling crust, Io's surface remains perpetually young, volatile, and ever-changing, a lava-lit moon with a molten heart, forever in motion. And so, our quiet gaze now settles upon Triton, Neptune's largest moon, which traces a unique path through the cosmos. It orbits its planet in the opposite direction of Neptune's own rotation, a motion known as a retrograde orbit. This gentle backward journey whispers a story of its origins, suggesting that Triton did not form alongside Neptune, but was likely a wanderer, captured long ago from the distant Kuiper belt. This ancient capture may have stirred a dramatic upheaval in Neptune's early days, perhaps even reshaping its original family of satellites. Triton itself is a world of quiet activity, graced with cryovolcanoes that softly release icy plumes into the vastness of space, and a thin, ethereal atmosphere that gently expands and contracts with the slow turning of its seasons. Cold, distant, and moving in a serene reverse, Triton remains a world that quietly defies our expectations at every turn. As our quiet gaze now turns to Earth's moon, we observe its unusually grand scale. When compared to the planet it orbits, our moon appears truly enormous. Indeed, no other rocky world within our solar system hosts such a relatively vast satellite. The moon's diameter is approximately 1/4 that of Earth, a proportion more commonly found in systems of dwarf planets and their companions, rather than with planets of Earth's stature. Most scientists gently suggest that our moon came into being after a body, perhaps the size of Mars, quietly collided with the young Earth. This ancient impact would have cast debris into orbit, which, over time, slowly gathered and coalesced into the tranquil orb we see today. This intimate partnership has, over billions of years, profoundly shaped Earth's tides, influenced its climate, and contributed to its enduring stability. Our moon is more than just a silent companion. It is a cosmic legacy, a quiet testament to planetary collision and the gentle renewal that follows. As we quietly observe the celestial dance, we find that planetary orbits are not, in fact, perfect circles. While our minds might often picture planets tracing flawless circular paths around the sun, their true journeys unfold along ellipses, gently stretched circles, with the sun resting slightly off-center. This graceful elliptical form means that each planet, in its slow, steady journey, reaches a point where it is closest to the sun, a moment known as perihelion, and another point where it drifts farthest away, called aphelion. For many of these cosmic wanderers, this difference is quite subtle, a gentle variation in their path, yet for others, like the swift Mercury and the distant Pluto, this distinction becomes more pronounced. These quiet shifts in distance subtly influence the changing seasons, the gentle touch of solar radiation, and the very speed of their orbital motion. This profound elliptical nature of planetary movement was first unveiled by Johannes Kepler in the 1600s, quietly reshaping our understanding of the solar system's elegant and timeless mechanics. And so, our quiet gaze now turns to the distant wanderers, those comets that journey from the very edge of interstellar space. The long-period comets, appearing only once every few millennia, are thought to originate from the Oort cloud, a vast, ethereal shell of icy debris that may extend nearly a light-year from our sun. These celestial travelers follow elongated, loosely bound orbits, often gently dislodged from their ancient resting places by the subtle gravitational whispers of passing stars or the slow, grand tides of our galaxy. As they begin their long inward fall toward the sun, they awaken, lighting up with spectacular tails that become visible even from our distant Earth. Some of these silent visitors may have spent billions of years drifting in the profound darkness before being softly nudged into their luminous motion. Their bright, fleeting returns offer us quiet glimpses into the solar system's most ancient, untouched matter, a serene echo from the dawn of time. In the quiet unfolding of cosmic time, our sun, like all stars, will eventually complete its luminous journey, destined to become a white dwarf. After approximately 5 billion more years, as its core's hydrogen fuel gently diminishes, it will begin a slow expansion, transforming into a red giant, a vast, glowing sphere that will softly embrace the inner planets. Following this grand phase, it will quietly shed its outer layers, forming a beautiful, ethereal shell of gas known as a planetary nebula. What remains will be its core, a dense, Earth-sized remnant composed primarily of carbon and oxygen, now a white dwarf. This celestial ember will no longer generate energy, but will instead cool with immense slowness over trillions of years. A quiet, persistent glow in the vast darkness, marking the serene conclusion of its stellar life. As our quiet gaze now settles upon Mars, we find a planet that, despite its colder and thinner atmosphere, experiences seasons much like our own Earth. This gentle rhythm of change is due to Mars possessing a similar axial tilt, approximately 25 degrees, which is quite close to Earth's own 23-degree inclination. As Mars quietly traces its path around the sun, this subtle tilt causes sunlight to caress different hemispheres more directly at various times of the year. The result is a serene cycle of spring, summer, autumn, and winter, each bringing its own gentle variations in temperature and light. These Martian seasons also quietly influence the polar ice caps, stir the occasional dust storm, and even bring about subtle changes in air pressure. Yet, they unfold with a slower, more deliberate pace than on Earth, for Mars takes nearly twice as long to complete its journey around the Sun. And so, our quiet journey now brings us to Ganymede, the largest moon in our solar system. This majestic satellite, quietly orbiting Jupiter, surpasses even the planet Mercury in its sheer size. With a diameter stretching over 5,000 kilometers, Ganymede cradles a rocky core, possibly a vast subsurface ocean, and a surface adorned with ancient scars and serene, ridged ice. What makes Ganymede truly unique is its gentle, self-generated magnetic field, which softly illuminates its thin atmosphere with shimmering auroras. Scientists quietly ponder the possibility of multiple layers of ocean nestled between sheets of ice, forming a complex and hidden internal world. Yet, despite its immense size and potential richness, Ganymede remains a quiet, dark sentinel, held gently within Jupiter's powerful magnetic embrace. In the quiet dance of the outer solar system, Pluto sometimes finds itself orbiting closer to the Sun than Neptune. While Pluto is generally perceived as the most distant of the classical dwarf planets, its path through space is gracefully elliptical, meaning there are periods when it gently sweeps inward, closer to our star than Neptune. This celestial alignment last occurred between the years 1979 and 1999, a time when Pluto temporarily held the position of the 8th planet from the Sun rather than the 9th. Yet, in this intricate ballet, these two worlds never collide or approach each other too closely, for their orbits are held in a delicate resonance. For every 3 serene orbits Neptune completes, Pluto quietly finishes exactly 2. This gravitational choreography ensures they maintain a stable, unhurried dance, their paths never truly crossing, a testament to the delicate balance governed by celestial rhythm and the vast expanse of time. Let us now quietly consider the Sun's profound dominance as its magnetic field gently reverses itself approximately every 11 Earth years. In this slow, rhythmic process, the north and south magnetic poles quietly exchange places. This grand cosmic ballet, known as the solar magnetic cycle, is intricately tied to the Sun's deep internal dynamics, subtly influencing all solar activity, from the appearance of sunspots to the gentle flares and the vast, slow ejections of coronal mass. At the peak of this cycle, a period we call solar maximum, the Sun becomes a little more active, radiating with a slightly more intense glow and stirring with gentle magnetic currents. As the cycle then quietly wanes, this activity gradually decreases, eventually reaching a serene solar minimum. These profound cycles, in their quiet unfolding, gently influence Earth's upper atmosphere, the silent satellites orbiting above us, and even the soft, dancing auroras that grace our polar skies. The Sun's magnetism, you see, is not a fixed, rigid force, but rather a soft, pulsing flow, much like a vast, breathing magnetic heartbeat across the cosmos. As we gently drift through the cosmic expanse, a common whisper sometimes emerges about planetary alignments, suggesting they might stir up natural disasters here on Earth. Yet, as we quietly observe the universe, there is no scientific evidence to support such dramatic effects. The gravitational embrace of other planets upon our world is truly minuscule when compared to the profound pull of our moon or the distant, powerful Sun. Even during those rare moments when planets align in a celestial ballet, their combined influence remains negligible, a soft whisper in the vastness. Our moon, being so intimately close, exerts a far greater impact on the gentle ebb and flow of our tides and the subtle stresses within Earth's crust than even the most massive yet distant worlds like Jupiter or Saturn. planetary alignments, in their quiet beauty, are a mathematically intriguing spectacle, a silent dance of distant worlds, not a celestial omen of disruption, but rather a peaceful, harmless arrangement in the grand cosmic design. To truly leave the embrace of our solar system is a journey measured in quiet decades, for escaping the profound gravitational pull of our sun is no small feat. Consider the spacecraft Voyager 1 and 2, launched gently into the cosmos in the 1970s. They have only recently, after more than 40 years, slipped into interstellar space. This is the serene region where the heliopause quietly gives way to the interstellar medium. These silent travelers, moving outward at speeds exceeding 60,000 kilometers per hour, have gracefully crossed the orbits of all the planets, drifted through the distant Kuiper Belt, and continued their solitary voyage into the deep, dark expanse. Their instruments, still softly humming, continue to function, and each carries a golden record, a quiet testament filled with the sounds of Earth, making them our gentle, enduring ambassadors to the vast galaxy beyond. As our quiet gaze now turns to Earth's protective embrace, we find an invisible magnetic field, a silent guardian surrounding our planet. This field is born from the slow, deep movements of molten iron within Earth's outer core, a gentle, internal dance that extends its influence far into space. It quietly deflects the charged particles streaming from the sun, forming a shield that safeguards our delicate atmosphere and the life-sustaining surface below from the harsh touch of solar and cosmic radiation. Without this serene protection, the solar wind might gradually erode our atmosphere, much as it is thought to have done on Mars, leaving a different, quieter world. This magnetic field also gently guides some of these particles toward the poles, where they softly interact with atmospheric gases, painting the sky with the shimmering curtains of the auroras, a quiet display of green, red, and violet light. Earth's magnetosphere is a dynamic yet profoundly peaceful shield, essential for preserving both the intricate tapestry of life and the delicate balance of climate across the vast stretches of geological time. In the quiet unfolding of cosmic time, our moon is gently, almost imperceptibly, moving away from Earth. Each year, this celestial companion drifts approximately 3.8 centimeters farther into the vastness. This slow, steady retreat is a consequence of the subtle, yet powerful tidal interactions between our two worlds. The gravitational embrace between Earth and the Moon creates gentle bulges in our planet's oceans, and these bulges, in turn, exert a delicate push, nudging the Moon slightly outward in its orbit. In the deep past, the Moon resided much closer to us, appearing significantly larger and more dominant in the night sky. As it continues its quiet recession, our days on Earth gradually lengthen, and the mesmerizing spectacle of eclipses will become less frequent and perhaps less dramatic. Billions of years from now, the Moon's orbit will have widened to such an extent that total solar eclipses, as we know them, will no longer grace our skies. The very fabric of our sky is slowly, quietly changing, even if we do not yet feel its profound shift. Beyond the familiar planets, the Kuiper Belt quietly cradles icy worlds, some adorned with surfaces that shimmer like distant mirrors. Far past the orbit of Neptune, this vast region not only hosts dwarf planets, but also smaller, tranquil, icy bodies, many possessing surprisingly bright exteriors. Consider Haumea, for instance, a gently spinning, football-shaped object, its surface softly coated in crystalline water ice. Then there is Eris, a world that reflects nearly all the sunlight that graces its distant face. making it one of the most reflective bodies within our solar system, even brighter than the softest, freshly fallen snow. These luminous qualities may whisper tales of resurfacing, perhaps through the gentle flow of cryovolcanism, the quiet touch of ancient impacts, or subtle chemical interactions over eons. In the deep, hushed darkness at the very edge of the sun's gentle reach, some of these distant worlds gleam softly, like cold, silent mirrors, catching the faintest whispers of sunlight in their frozen, eternal quiet. Our quiet journey now brings us to Saturn's tiny moon, Enceladus, a world that, despite its modest size, holds a truly spectacular secret. From its south pole, towering geysers of water vapor and delicate ice crystals gently erupt into the vastness of space, emerging through deep fissures often referred to as tiger stripes. These ethereal plumes are quietly powered by a gentle tidal heating deep beneath the surface, where the subtle friction caused by Saturn's immense gravitational pull maintains a hidden subsurface ocean in a liquid state. The material carried within these plumes whispers tales of organic compounds, various salts, and even faint signs of hydrothermal activity, softly raising the tantalizing possibility of life within its depths. As these icy particles drift away, some quietly escape into space, helping to replenish Saturn's expansive E-ring, thus creating a living, flowing connection between this small moon and its grand parent planet. As we continue our gentle drift, we find that some asteroids are not solid rock, but rather quiet accumulations of cosmic debris. Many of these celestial wanderers are simply loose collections of stones, gravel, and dust, held together by the subtle embrace of gravity. These are known as rubble piles, fragile bodies that can slowly form after ancient collisions shatter larger asteroids, with the scattered fragments gradually reassembling over vast stretches of time. Such rubble pile asteroids may harbor large internal voids, exhibit peculiar spins, and even subtly change their shape under the gentle pressures of space. Missions like Hayabusa 2 and OSIRIS-REx have quietly journeyed to these bodies, confirming their delicate, porous nature. They are not monolithic relics, but rather chaotic, yet serene assemblages, ancient drifting ruins of early planetary construction that barely hold themselves together as they continue their silent orbit around the Sun. As we gently approach the innermost planet, Mercury, we observe a fascinating characteristic. Its core is disproportionately large. Though Mercury itself is a small world, it cradles an unusually massive iron core within its depths. This dense metallic center quietly accounts for approximately 80% of the planet's entire radius, a far greater proportion than what we find within Earth or Venus. The precise reason for this oversized core remains a gentle whisper of uncertainty in the cosmic narrative. Some scientists quietly ponder the idea that Mercury once possessed a much thicker rocky mantle, which may have been gently stripped away by a colossal impact in its distant past. Others suggest that its formation so close to the Sun, where powerful solar forces were at play, might have favored the gradual accumulation of heavier elements. The quiet result of these ancient processes is a planet with a remarkably thin crust, a vast, heavy core, and a subtle, weak magnetic field, a metal-rich survivor quietly enduring from the solar system's chaotic youth. As our gentle journey continues, we find ourselves observing Venus, a world that drifts through space entirely without the company of a moon. Among the rocky planets, only Mercury and Venus share this solitary existence, devoid of natural satellites. While Mercury's close embrace with the Sun might offer a quiet explanation for its lack of moons, Venus's situation holds a touch more mystery. It is a planet of similar size to our own Earth, which is graced by a large luminous moon, yet Venus orbits alone. Some quiet theories suggest that it may have once cradled a moon, perhaps one that gently returned to the planet's embrace or was lost in a distant, ancient collision. Other contemplations propose that Venus's remarkably slow, backward rotation might subtly prevent stable orbits from forming around it. Whatever the quiet reason, Venus continues its celestial dance, a bright, cloud-wrapped world with no lunar companion to grace its twilight skies. In the quiet expanse of our solar system, a gentle truth unfolds. Most of the celestial companions we call moons gracefully orbit the gas giants. While our own Earth holds just one luminous moon and Mars cradles two tiny captured companions, the colossal planets of the outer solar system are encircled by vast, intricate systems of satellites. Jupiter and Saturn, in their majestic dance, each host dozens of confirmed moons, their sizes ranging from small, captured asteroids to magnificent worlds like Ganymede and Titan, each with its own quiet story. Further out, Uranus and Neptune also embrace many icy moons, some tracing complex orbits, others perhaps concealing hidden oceans beneath their frozen surfaces. These gas giants, in their profound gravitational embrace, act like miniature solar systems, their immense pull steadily gathering cosmic debris and allowing satellites to slowly coalesce over eons. It seems that the farther one drifts from the sun's warm glow, the more companions gravity quietly gathers in the cold, silent depths of space. From its tranquil vantage point, the Hubble Space Telescope has quietly observed and photographed the distant planets of our solar system. Though it orbits just above our own Earth, Hubble has managed to capture remarkably detailed images of the outer worlds, revealing the intricate cloud bands that swirl across Jupiter, the majestic storms that drift through Neptune's atmosphere, and even the subtle seasonal changes unfolding on Mars. These serene images offer a continuous, long-term observation, gently complementing the fleeting glimpses provided by spacecraft flybys. They allow us to witness the slow evolution of weather patterns, the delicate dance of ring systems, and the ethereal glow of planetary auroras. With its exceptional clarity, Hubble enables scientists to quietly track the development of storms, to monitor the rare, gentle impact events, and to study the atmospheres of these worlds in the soft light of ultraviolet and visible wavelengths. From its quiet perch, Hubble not only gazes upon the distant galaxies, but also watches the ever-shifting faces of our neighboring worlds, a silent sentinel in the cosmic ocean. In the quiet unfolding of cosmic time, our gaze now settles upon Jupiter, a giant world where a timeless phenomenon continues its slow, majestic dance. Here, in the southern hemisphere, swirls the great red spot, a colossal storm, vast enough to gently embrace 2 or even 3 of our Earths within its swirling expanse. For at least 350 years, and perhaps even longer, this immense vortex has been turning, a silent testament to the enduring power of planetary forces. When it was first glimpsed through the early telescopes of the 1600s, it was already a marvel. Over the centuries, it has subtly transformed, gradually diminishing in size, yet never losing its profound strength. The distinctive reddish hue that colors this ancient storm may whisper of complex chemical reactions unfolding within Jupiter's deep atmosphere, perhaps gently stirred by distant sunlight and the delicate interplay of high-altitude compounds. Along its outer edges, the winds move with a quiet, steady power, exceeding 400 kilometers per hour. While storms on our own planet may last for days or weeks before fading, this Jovian tempest, cradled within the planet's turbulent belts, continues its serene, centuries-long journey. As our gentle journey continues, we find ourselves quietly observing Neptune, a world that radiates more heat than it receives from the distant sun. Though it drifts far from the sun's warmth, Neptune is not merely a frozen, inert sphere. In a fascinating cosmic paradox, it quietly radiates approximately 2.6 times more energy than it absorbs. This subtle internal warmth gently fuels its powerful winds and vast storm systems, including some of the fastest ever recorded within our solar neighborhood. The precise origin of Neptune's enduring heat remains a quiet mystery, with possibilities including the lingering energy from its ancient formation, a slow, gentle gravitational contraction, or perhaps the quiet decay of radioactive elements deep within its core. Despite its immense distance from the sun, Neptune reveals itself as a world of surprising, subtle energy, a planet with a serene, cold exterior, yet a warm, restless interior, perpetually reshaping its windswept atmosphere in the quiet depths of space. As our gentle journey now carries us to our home, Earth, we observe a truly unique phenomenon: the presence of water in all three of its states. Our planet quietly distinguishes itself, allowing water to exist naturally across its surface as a solid, a liquid, and a gas. Imagine the serene expanse of ice caps and glaciers, the vast, calming oceans and tranquil lakes, and the soft, drifting clouds and vapor, all coexisting and cycling gently through the atmosphere, across the land, and within the deep sea. This delicate balance, so crucial for the quiet unfolding of life, is carefully regulated by Earth's gentle distance from the sun, its atmospheric pressure, and its remarkably stable climate. While other worlds may hold water in isolated forms, perhaps as icy crusts, or as vapor in thin, ethereal atmospheres, or even in hidden subsurface oceans, none display the same dynamic, planet-wide presence. Here on Earth, water flows, freezes, and evaporates in a never-ending, life-sustaining dance, a quiet rhythm that cradles all existence. Our gentle journey now carries us to the heliopause, a serene boundary marking the very edge of the sun's direct influence. Here, the solar wind, a gentle outflow of particles from our star, quietly meets the interstellar medium, the delicate gas and dust that drifts between the stars. This cosmic meeting point defines the outer edge of the heliosphere, a protective bubble that cradles our solar system. Beyond this quiet frontier, the subtle pressures from other stars and galactic particles begin to outweigh the solar wind's gentle push. It was here that Voyager 1 in 2012 and then Voyager 2 in 2018 softly crossed into the true interstellar space. While the sun's gravity still extends its silent reach much farther, the heliopause signifies the quiet end of its energetic breath, a final whisper of solar influence before the profound depths of deep space truly begin. Our entire solar system, in its own quiet way, is gently drifting through a local cloud within this vastness. Our entire solar system, in its quiet cosmic journey, is presently moving through a particular region of space known as the local interstellar cloud. This is a delicate concentration of gas and dust, stretching approximately 30 light-years across, and it exists as a smaller part of a much larger structure, gently referred to as the local bubble, which was quietly sculpted by ancient supernova explosions. As our sun gracefully travels through this ethereal cloud, at a serene pace of about 7,000 kilometers per hour, its heliosphere acts like a protective, invisible shield, softly deflecting the interstellar material that it encounters. Scientists, with their quiet curiosity, study this cloud to gently unravel how interstellar conditions might subtly influence cosmic rays, shape the heliosphere, and perhaps even touch the climate here on Earth. We are not simply still in space, rather, we are slowly and silently sailing through a vast galactic fog, a gentle, unending drift. As we continue our gentle exploration, we find that geological activity is not solely confined to the planets themselves. Indeed, several moons throughout our solar system quietly reveal signs of their own internal energy and ongoing surface transformations. Consider Io, a moon gracefully orbiting Jupiter, intricately riddled with active volcanoes, their fiery energy fueled by the gentle, rhythmic pull of tidal heating. Meanwhile, Enceladus, a serene companion to Saturn, softly vents plumes of water vapor into the silent expanse of space, and beneath their icy shells, Europa and Ganymede likely cradle vast subsurface oceans, gently stirred by an inner warmth. Even distant Triton, Neptune's captured moon, whispers tales of cryovolcanism, where icy eruptions are quietly driven by shifting pressures deep within. These moons are far from static, frozen spheres. They are restless, dynamic worlds, holding within them a geology, a chemistry, and perhaps even the quiet potential for biology, hidden beneath their tranquil, frozen exteriors. In the quiet dance of the outer solar system, Pluto's atmosphere performs a gentle, rhythmic vanishing act. Though this distant world is small and profoundly cold, it quietly maintains a thin veil of gases, composed mostly of nitrogen, with whispers of methane and carbon monoxide. As Pluto gracefully approaches the Sun along its elongated elliptical path, the surface ices begin to warm ever so slightly, transforming into gas and forming a delicate, hazy envelope that softly expands into the surrounding space. Yet, as it drifts farther away, the atmosphere gradually cools and gently collapses, its gases freezing once more onto the surface like a delicate cosmic frost. This serene cycle unfolds over Pluto's long, 248-year orbit. During the New Horizons flyby in 2015, this ethereal atmosphere was observed as a beautifully layered blue haze, a fleeting, tender breath of warmth around a world that quietly spends most of its vast journey in the profound stillness of cosmic winter. Deep within the Sun's luminous heart, temperatures quietly ascend to more than 15 million degrees Celsius. It is here, at the very center, that hydrogen atoms are gently compressed under immense silent pressure until they begin to fuse into helium. This profound transformation releases an enormous, steady flow of energy, a quiet power that fuels the Sun's gentle light and warmth, and in turn, sustains all life on our distant Earth. The energy born in this fiery core embarks on an incredibly long journey, taking hundreds of thousands of years to slowly make its way to the surface, softly bouncing through dense layers of plasma. Once it finally escapes into the vastness, this energy then travels across space in just a little over 8 minutes to reach us, a gentle whisper of light from a distant, powerful source. The Sun's radiant, calm exterior quietly conceals an unimaginably hot and profoundly energetic heart. Our quiet journey now brings us to Uranus, a world that also possesses a faint, tilted ring system. While Saturn's magnificent rings are perhaps the most iconic, Uranus, too, is encircled by these delicate structures. There are 13 known rings, though they are considerably darker and much fainter, composed of tiny particles of rock and ice. These ethereal bands quietly orbit in alignment with Uranus's unusual, almost sideways tilt. Because the planet itself lies nearly on its side, its rings appear to stand vertically when observed from a vantage point above the Sun's north pole. Some of these rings are remarkably narrow and possess sharp edges, a characteristic that scientists believe might be gently shaped by small, unseen moons, quietly shepherding their delicate structures. These subtle rings remained undiscovered until 1977, when they were quietly revealed as they momentarily blocked the light of a distant background star. They remain as subtle, shadowy bands, softly circling a planet that drifts through space on its side. Imagine, if you will, a vast magnetic bubble, gently blown by the sun itself. This is the heliosphere, a serene expanse formed by the solar wind, a steady stream of charged particles that quietly flows outward in every direction. It creates an immense, protective magnetic field that envelops our entire solar system, acting as a soft shield against the more energetic galactic radiation from beyond. Quietly shaped by the sun's activity and the subtle pressures of interstellar space, this cosmic bubble stretches far beyond the orbit of Pluto, softly enclosing all the familiar planets, distant comets, and other celestial wanderers. Its outermost boundary, known as the heliopause, marks the tranquil place where the sun's gentle influence gradually fades into the wider galaxy. As our sun, with its planetary companions, quietly orbits the Milky Way, the heliosphere moves along with it, silently safeguarding our solar system as it drifts through the ever-changing regions of interstellar space. In the quiet unfolding of cosmic time, our understanding of Mercury's gentle path around the sun offered a profound confirmation of Einstein's theory of gravity. For many centuries, astronomers had observed a subtle peculiarity in Mercury's orbit. Its closest approach to the sun, a point known as perihelion, seemed to shift ever so slightly over time, a movement that Newtonian physics alone could not fully explain. Then, in 1915, Albert Einstein's theory of general relativity emerged, quietly offering a beautiful solution. According to this elegant theory, immense objects like our sun gently warp the very fabric of space-time, subtly altering the paths of planets as they drift. The small yet precisely measurable effect on Mercury's orbit aligned perfectly with Einstein's predictions. This quiet alignment became one of the very first experimental confirmations of his revolutionary theory, a serene triumph of mathematics, softly illuminating a charming quirk in the motion of this scorched, rocky world. As we gently consider our own planet, we find the moon quietly shaping Earth's tides. The rhythmic rise and fall of the ocean waters, a daily ballet, is largely orchestrated by the moon's gentle gravitational embrace. As the moon's gravity softly tugs upon our planet's vast oceans, it subtly draws the water, creating gentle bulges on the side facing the moon, and another on the opposite side. Then, as Earth slowly rotates, these watery bulges drift across the globe, giving rise to the familiar rhythm of high and low tides. The sun, too, plays its part in this cosmic dance, its own gravitational influence creating the varying strengths of spring and neap tides, depending on its alignment with the moon. These subtle tidal forces extend beyond the oceans, quietly shifting the Earth's very crust and even influencing the planet's slow, steady rotation. The moon's silent presence keeps the oceans in their eternal, soothing motion. Quietly, in the distant reaches of our solar system, there may be undiscovered worlds beyond Neptune. Astronomers have observed that certain far-off objects within the Kuiper Belt follow clustered, elongated orbital paths that cannot be easily accounted for by the gravitational pull of our known planets. One gentle theory suggests that a large, as yet undetected planet, sometimes referred to as Planet 9, might be subtly influencing these distant trajectories with its unseen gravity. If it truly exists, this hidden world would likely possess several times the mass of Earth and would quietly orbit far beyond Pluto, taking thousands of Earth years to complete a single slow revolution around our Sun. While no direct evidence has yet confirmed its presence, telescopes are patiently searching the deep, dark skies. Should it ever be found, it would softly reshape our understanding of the solar system's outermost architecture, adding another layer to its quiet, cosmic tapestry. Our gentle cosmic journey now brings us to Callisto, a moon of Jupiter, where beneath its icy surface, an ocean may quietly reside. This celestial body appears serene and ancient, its cratered face untouched by recent geological stirrings. Yet, deep beneath that frozen crust, scientists gently ponder the possibility of a subsurface ocean, kept in a liquid state by subtle internal heating, perhaps a lingering warmth from its very formation. Magnetic readings, gathered by the Galileo spacecraft, once offered a quiet hint of a conductive layer beneath the surface, a layer consistent with the presence of salty water. If this deep, hidden sea is confirmed, Callisto would softly join Europa and Ganymede as another world cradling an ocean. Though perhaps less known, Callisto's deep, dark waters could hold the quiet ingredients for life, silently sealed away beneath a shell of ice and the slow passage of time. As we gently consider the planets, it may seem surprising that Venus, though farther from the Sun, holds surface temperatures hotter than Mercury. While Mercury is indeed the closest to our star, Venus claims the record for the most extreme heat, a quiet testament to the power of its atmosphere. This intense warmth is due to an incredibly thick blanket of carbon dioxide, which gently traps heat in a runaway greenhouse effect. On Venus, surface temperatures quietly exceed 460 degrees Celsius, a warmth sufficient to melt lead. The dense clouds, while reflecting sunlight, also prevent this trapped heat from ever truly escaping. Meanwhile, Mercury, with its delicate exosphere, lacks such insulation, allowing its dark side to cool rapidly into the deep chill of space. Venus's searing heat, then, is not merely about its proximity to the Sun, but rather about the profound influence of its atmosphere and the silent power of trapped radiation. Our journey now brings us to the majestic rings of Saturn, which are composed mostly of ice. Though they shimmer like solid, continuous bands, Saturn's rings are, in truth, made of countless individual particles, predominantly water ice, ranging in size from tiny grains of dust to chunks as large as houses. These icy fragments drift in orbit within an incredibly thin, flat disk, held in their graceful dance by Saturn's immense gravity and the subtle influence of its nearby moons. The ice grants these rings their brilliant reflectivity, making them one of the most luminous features in our solar system when viewed from afar. Quietly embedded within these rings are narrow gaps, gentle wave patterns, and delicate ringlets, all sculpted by gravitational resonances. The rings are dynamic, ever-changing structures, a serene ballet of ice caught in perpetual motion. Meanwhile, in the asteroid belt, Ceres exists as both an asteroid and a dwarf planet. Located between the orbits of Mars and Jupiter, Ceres is the largest object in that vast region, so substantial in fact that it quietly qualifies as a dwarf planet. Discovered in 1801, Ceres possesses a spherical shape, unlike the more irregular forms of smaller asteroids, and may even harbor a subsurface layer of briny water or mud. NASA's Dawn spacecraft once revealed mysterious bright spots upon its surface, which were later understood to be deposits of salt, perhaps left behind by water that had gently evaporated. Ceres is a hybrid world, neither entirely a planet nor a typical asteroid, offering us a quiet glimpse into the early ingredients of planetary formation. As we continue our drift, we observe that Mars appears red because of rust. The surface of Mars is softly coated in a fine dust of iron oxide, the very same compound that imparts rust with its familiar color. Over billions of years, this iron-rich material has slowly oxidized in the thin Martian atmosphere, creating the planet's signature reddish hue. This pervasive dust is so widespread that it colors the sky during storms and gently coats the entire planet. Despite this rusty appearance, Mars also reveals dark basaltic plains and polar ice caps, creating subtle color variations across its vast surface. Yet, from a distance, that distinctive reddish tone quietly dominates, a dusty signal of oxidation on a cold desert world. Deep within the sun's luminous heart, temperatures quietly soar, yet some spots appear cooler regions on its surface. Though the sun's surface blazes at thousands of degrees, certain areas appear darker, not because they are truly cold, but because they are simply cooler than their brilliant surroundings. These are sunspots, temporary regions where intense magnetic activity gently suppresses the outward flow of heat. Sunspots can grow larger than Earth and often appear in quiet pairs or clusters. They follow an 11-year cycle, growing more numerous and active as the sun approaches its solar maximum. Despite their name, they remain incredibly hot, thousands of degrees, but the stark contrast makes them appear dark. These spots are like magnetic scars, quietly revealing the sun's ever-changing internal rhythms. Our quiet journey now brings us to Uranus, a planet that was discovered by telescope. Unlike the planets visible to the naked eye since ancient times, Uranus was not officially identified until 1781, when astronomer William Herschel observed it through his telescope. At first, he gently thought it might be a comet or a distant star, but further observations quietly confirmed its planetary motion. Uranus thus became the first planet discovered in modern times, softly expanding the known boundaries of our solar system. Its discovery marked a quiet shift from naked-eye astronomy to instrument-based exploration. Since then, Uranus has revealed many surprises, from its extreme axial tilt to its faint rings and icy moons. It is a planet that quietly rewrote the map of the night sky. As we consider the vastness of time, we find that the solar system is about 4.6 billion years old. By studying ancient meteorites, radioactive isotopes, and the oldest rocks found on Earth and the Moon, scientists have gently traced the age of our solar system to approximately 4.6 billion years. It began as a swirling cloud of gas and dust, a solar nebula, which slowly collapsed under its own gravity, forming the sun at its luminous center. The remaining material quietly coalesced into planets, moons, asteroids, and comets. This process of accretion and differentiation laid the quiet foundation for everything that followed. The planets we see today are the serene survivors of a chaotic beginning, shaped by collisions, migrations, and long, slow cooling. In the asteroid belt, Vesta reveals a layered structure much like a planet. Vesta, the second largest object in this belt, is not merely a simple rock. It is a protoplanet with differentiated layers. Beneath its surface lies a mantle and a dense metallic core, a structure remarkably similar to the internal composition of Earth and other terrestrial planets. This suggests that Vesta once possessed enough internal heat to melt and separate into these distinct layers, a process known as planetary differentiation. The giant impact that carved out the Rhea Silvia crater at its south pole may have quietly exposed some of these deeper layers. Vesta is a frozen fossil, a planetary building block that never quite achieved full planet status, yet holds the quiet memory of a more dynamic past. Though it appears still and silent, the moon occasionally experiences quakes. These moonquakes can be gently caused by tidal forces from Earth's gravity, by thermal expansion as the lunar surface slowly heats and cools, or even by the quiet impact of meteorites. Some quakes originate deep within the moon and can last for up to an hour, a duration far longer than earthquakes on Earth. Data from the Apollo missions first revealed these subtle shakes, and new instruments continue to study them. Though the moon possesses no tectonic plates, its quakes quietly suggest an interior that is not entirely dormant, a solid world with a quiet, pulsing heart. Our journey now brings us to Triton, a captured moon. Neptune's largest moon, Triton, is unique among major moons because it orbits in the opposite direction of its planet's rotation, a retrograde orbit. This unusual path gently suggests that Triton did not form around Neptune, but was captured from the Kuiper Belt long ago. The gravitational disruption from this capture may have quietly destroyed Neptune's original moons and tilted Triton's own interior, causing tidal heating. Today, Triton exhibits geysers that gently spew nitrogen into space, a thin atmosphere, and a frozen surface marked by strange cantaloupe-like textures. It is both a relic of the outer solar system and a moon shaped by a violent, yet distant, adoption. As we drift further, we find that Neptune has 14 known moons. Neptune, the farthest major planet from the Sun, is orbited by at least 14 moons, ranging from the large and mysterious to the small and irregular. The largest, Triton, accounts for most of the mass, but others like Proteus, Naiad, and Larissa follow eccentric and varied paths. Some are likely captured Kuiper Belt objects, while others may have formed from ancient collisions or debris. Most of these moons are icy and dark, reflecting very little sunlight. Their orbits offer quiet clues about Neptune's violent past and possible planetary migrations. Together, they form a scattered family of companions around a planet that drifts on the solar system's distant, serene edge. In a remarkable feat of engineering, the Parker Solar Probe is gently touching the Sun. Launched in 2018, NASA's Parker Solar Probe is the first spacecraft to fly directly into the Sun's outer atmosphere, known as the corona. It moves at extraordinary speeds, faster than any object ever built, and endures temperatures of over 1,000 degrees Celsius. Protected by a carbon composite heat shield, the probe dips closer with each orbit, quietly gathering data on solar wind, magnetic fields, and energetic particles. Its mission is to solve long-standing mysteries, such as why the corona is hotter than the Sun's surface and how solar flares accelerate. In a sense, it is not just studying the Sun, it is gently flying through it. Quietly, some meteorites on Earth came from Mars. Though Mars is millions of kilometers away, pieces of it have, over vast spans of time, landed on Earth. These are Martian meteorites, fragments of rock gently blasted off the Martian surface by powerful impacts, which then traveled through the quiet vacuum of space and eventually fell into our atmosphere. Scientists identify them by comparing their chemical makeup to data collected by Mars, rovers, and orbiters. Some of these meteorites contain tiny bubbles of trapped Martian air and minerals shaped by water, offering direct, quiet clues to Mars's geological and chemical history. These wayward stones are like samples from another world, sent to us by nature long before any spacecraft returned the favor. As we gaze upon the sun, we recognize that it is mostly hydrogen and helium. Approximately 70% of the sun's mass is hydrogen, and most of the remainder is helium. These two lightest elements quietly dominate its makeup and fuel the nuclear fusion at its core. Under extreme pressure and heat, hydrogen atoms are gently fused into helium, releasing vast amounts of energy. The remaining 1 to 2% of the sun's mass includes oxygen, carbon, nitrogen, and heavier elements, all of which originated in earlier generations of stars. Despite its brilliance and complexity, the sun is fundamentally simple in composition, a glowing sphere of primordial gases shaped by gravity and nuclear fire. Our quiet planet's tilt gives us seasons. Earth's axis is tilted about 23.5 degrees relative to its orbit around the sun. This gentle tilt is the profound reason we experience seasons. When one hemisphere is tilted toward the sun, it receives more direct sunlight and longer days, quietly resulting in summer. When tilted away, the sunlight is weaker and days are shorter, bringing winter. Without this tilt, seasons would barely exist, and most of Earth's climates would be far more uniform. The tilt has shifted slightly over time due to gravitational influences from the Moon and other planets, but it remains one of the quiet architects of life's seasonal rhythms. As we consider the giants of our solar system, we find that Jupiter's magnetosphere is the largest structure. Jupiter's immense magnetic field extends millions of kilometers into space, forming a magnetosphere so vast it would appear larger than the sun in the night sky if it were visible. This field is powered by electric currents within the planet's metallic hydrogen interior. Within the magnetosphere, charged particles gently zip along magnetic lines, creating intense radiation belts, massive auroras, and fierce electrical storms. The field captures particles from Io's volcanic eruptions and quietly shapes the orbits of nearby moons. For spacecraft, the radiation here poses a major hazard. For scientists, it is a laboratory for studying planetary magnetism at its most extreme. Though they appear timeless, planetary rings may be temporary. Planetary rings, like those around Saturn, Jupiter, Uranus, and Neptune, may be relatively short-lived on cosmic timescales. Rings form from shattered moons, leftover debris, or icy particles gently pulled into orbit. But over millions of years, these materials can slowly spiral inward due to gravity, magnetic drag, or collisions, eventually falling onto the host planet. Observations suggest Saturn's rings may be less than 100 million years old and could quietly vanish within another 100 million. The rings we see today may be a fleeting phase, a spectacular, shimmering moment in a planet's much longer life. As we gaze upon our closest celestial neighbor, we notice that the moon's surface barely changes over time. Without wind, rain, or active geology, the moon's surface remains almost entirely unchanged for millions, even billions of years. Footprints left by astronauts will likely remain preserved for thousands of generations. Micrometeorites and cosmic radiation are the main forces that slowly wear down the lunar landscape, causing a gradual erosion known as space weathering. Craters from ancient impacts still quietly dominate the terrain, creating a record of collisions going back to the solar system's earliest days. The moon is not only Earth's closest neighbor, but also one of its oldest and most faithful geological archives. Beneath the icy crusts of moons like Europa and Enceladus, scientists believe some icy moons may have hydrothermal vents. Subsurface oceans may gently touch hot rocky cores, forming hydrothermal vents similar to those found on Earth's ocean floor. On our planet, such vents quietly support entire ecosystems without sunlight, using chemical energy from minerals and heated water. If similar vents exist on these distant moons, they could provide the conditions necessary for life: water, heat, and a steady energy source. Plumes from Enceladus even contain compounds associated with biological processes. These hidden underwater worlds may be the most promising places to search for life beyond Earth, whispering possibilities in the cosmic dark. As we feel the warmth of the sun, we remember that sunlight takes over 8 minutes to reach Earth. The light that warms your skin and brightens the sky began its journey deep in the sun's core, where nuclear fusion quietly creates photons. These photons then take hundreds of thousands of years to travel from the sun's center to its surface, gently bouncing and scattering through dense plasma. Once they escape the surface, however, they travel the remaining distance to Earth, about 150 million kilometers, in just over 8 minutes. When you watch a sunrise or look at the midday sun, you're seeing it not as it is, but as it was 8 minutes ago, a quiet glimpse into the very recent past. Our journey now brings us to Europa, where its cracked ice may shift like tectonic plates. The surface of Jupiter's moon, Europa, is covered in a shell of ice crisscrossed with dark lines, ridges, and chaotic terrain. These features gently suggest the ice may be moving, breaking, sliding, and even subducting like Earth's tectonic plates. If true, Europa would be the only known body besides Earth with active plate-like motion. This process could help cycle nutrients between the surface and the ocean below, quietly increasing the moon's habitability. The driving force is likely tidal flexing from Jupiter's immense gravity, which continually kneads Europa's interior. It's a frozen world, but not a static one, holding secrets beneath its serene surface. As we consider the gas giants, we find that Saturn is less dense than water. If you could place Saturn in a giant cosmic bathtub, it would gently float, not because it's hollow, but because its average density is less than that of water. Saturn is composed mostly of hydrogen and helium, giving it a lightness despite its massive size. Its volume is enormous, more than 700 times that of Earth, but its mass is only about 95 times greater. This low density gives Saturn a gentle, diffuse structure, with rapid rotation that subtly flattens it at the poles and bulges it at the equator. It's a giant of gas, softly puffed into shape by gravity and motion. From time to time, solar flares can disrupt technology on Earth. Solar flares are sudden, powerful eruptions of energy from the sun's surface, often linked to sunspot activity. These outbursts release intense bursts of radiation across the electromagnetic spectrum, including X-rays and ultraviolet light. When directed toward Earth, they can disturb the upper atmosphere, quietly affecting GPS systems, radio communications, and satellite operations. In extreme cases, they can trigger geomagnetic storms, potentially damaging power grids. While Earth's magnetic field offers protection, flares gently remind us that the sun is not a steady light bulb, but a dynamic, volatile star, one that occasionally sends ripples of energy pulsing across the solar system. Our quiet skies are often painted by the solar cycle, which influences auroras. Auroras, the shimmering curtains of green, red, and violet light near Earth's poles, are caused by charged solar particles interacting with Earth's magnetic field and atmosphere. These displays become more frequent and intense during periods of high solar activity, which follow an 11-year cycle. During solar maximum, increased sunspot activity and solar flares send more particles hurtling toward Earth, fueling brighter auroras. During solar minimum, the lights are quieter. The sun's magnetic fluctuations ripple outward, and we see them in our skies, a reminder that space weather can paint the heavens in subtle solar brushstrokes. As a comet approaches the sun, its tail always points away from the sun. As a comet draws near our star, its icy surface begins to sublimate, gently releasing gas and dust that form a glowing tail. But contrary to intuition, the tail does not trail behind the comet like smoke behind a train. Instead, it points away from the sun, no matter which direction the comet is moving. This is because solar wind and radiation pressure gently push the material outward, forming two distinct tails, a curved dust tail and a straight bluish ion tail. The result is a luminous, wind-swept signature, quietly tracing the invisible force of sunlight through the darkness of space. In the chaotic early days of our solar system, some planetary moons formed from giant impacts. Earth's moon is believed to have formed from a colossal impact between the early Earth and a Mars-sized body over 4 billion years ago. The collision ejected material into orbit, which gradually coalesced into the moon. Similar impact origins are suspected for other moons, such as Pluto's Charon. These violent beginnings contrast with the captured moons of the outer planets, showing that no single process explains all satellites. Some moons were born of fire and collision, others from gentle gravitational snaring. The diversity of their origins mirrors the chaos and creativity of the solar system's formative years. Far beyond our familiar planets, Voyager 1 carries a golden record into deep space. Launched in 1977, Voyager 1 now travels through interstellar space, farther from Earth than any other human-made object. Attached to its side is a golden record, a phonograph disc containing sounds and images chosen to represent life on Earth. It includes greetings in dozens of languages, music from around the world, and recordings of waves, birdsong, and laughter. Designed by a team led by Carl Sagan, the record is meant for any intelligent beings who might someday find it. It's a message in a bottle, quietly cast into the galaxy, a gentle greeting from our pale blue dot. As Earth orbits the Sun, it shares its path with co-orbital asteroids. Although Earth orbits the Sun alone in its primary path, it quietly shares its general region of space with small bodies known as co-orbital asteroids. These objects do not orbit Earth like moons, but instead follow stable, looping paths near Earth's orbit, shaped by gentle gravitational interactions. Some, called Trojans, hover around stable Lagrange points ahead of or behind Earth. Others follow horseshoe-shaped paths that keep them near but never colliding. These quiet companions are often temporary, captured and released over thousands of years. Invisible to the naked eye, they drift near us in space, fellow travelers on our yearly journey around the Sun. Before Neptune was officially discovered in 1846, it was once confused with Uranus. Some early astronomers may have observed it without realizing what it was. Because it moves so slowly and appears so dim, it was occasionally mistaken for a fixed star or thought to be another sighting of Uranus. In fact, Galileo may have unknowingly seen Neptune through his telescope in 1612 and marked it as a star. It wasn't until mathematicians noticed irregularities in Uranus's orbit that Neptune's existence was predicted and quietly confirmed. In a sky filled with wandering points of light, Neptune remained hidden in plain sight for centuries. Our understanding of the solar system's boundaries reveals that its edge isn't defined by gravity. The Sun's gravitational pull extends far beyond Pluto, gently holding on to distant comets and icy bodies in the Oort cloud. But when scientists speak of the edge of the solar system, they often refer to the boundary of the heliosphere, the region where the solar wind meets the interstellar medium. This edge, called the heliopause, marks the point where the influence of the sun's magnetic field and particle flow ends. Gravity continues far beyond, but the energetic boundary is where the space between stars quietly begins. It's a subtle, shifting frontier, more a change in pressure than in presence. Even thick atmospheres like Earth's are not permanent. Planetary atmospheres slowly leak into space. Over time, light gases like hydrogen and helium can escape a planet's gravity and gently drift off into space. This process, known as atmospheric escape, is more pronounced on smaller planets with weaker gravity, such as Mars and Mercury. On Venus, a lack of magnetic shielding has allowed the solar wind to quietly erode parts of its upper atmosphere. Earth loses thousands of tons of hydrogen each year. Though it's easily replenished, the slow escape of gases is a quiet leak into the void, a constant exchange between planets and the vacuum beyond. Just as ring systems can decay into planets or vanish over time, some moons may have formed from ring systems. In Saturn's case, it's possible that some of its small outer moons originally coalesced from ring material that clumped together beyond the planet's Roche limit, the boundary beyond which gravity can pull matter into moons rather than tear it apart. Moons like Pan and Daphnis, which orbit within Saturn's rings, may still be accreting material from them today. These moonlets serve as quiet sculptors of the rings, their gravity carving gentle gaps and waves into the icy bands around them. More than 45 years after its launch, Voyager 1 is still sending data from interstellar space. It continues to transmit faint signals back to Earth, even as it travels through the interstellar medium billions of kilometers from home. Its instruments measure cosmic rays, magnetic fields, and plasma density in the space between stars. Power is limited, and systems are gradually being turned off to conserve energy, but the spacecraft still functions. It uses a tiny nuclear power source and communicates via the deep space network. Every signal takes more than 20 hours to reach Earth, a whisper from the very edge of human exploration. As we consider our place in the cosmos, we realize that the solar system completes a galactic orbit every 225 million years. While the planets orbit the sun itself is also moving, revolving around the center of the Milky Way galaxy. It takes roughly 225 to 250 million years to complete one orbit, a journey sometimes called a cosmic year. During that time, the solar system drifts through different regions of interstellar space, potentially passing through galactic arms, star-forming regions, and clouds of gas and dust. This motion may influence comet activity, and on longer timescales, even Earth's climate. We are not fixed in space, but part of a vast, slow spiral, riding the galaxy's arm like a cosmic carousel. And so, our quiet journey through the solar system comes to a gentle close. From the inner world scorched by sunlight to the icy moons that whisper in the dark, we've wandered together through orbits, storms, and shadows, one sleepy fact at a time. If your eyes are already heavy, that's just fine. Let the last traces of starlight fade behind your thoughts, and let your breath carry you softly into rest. There's still so much more to discover, but for now, you've learned enough. You've traveled far, and the universe can wait until morning. Thank you for spending this time with me. And so, under the quiet stars, the story continues. I hope you sleep well and dream softly. Good night.